Okay, so I was at a math training all day today. I was learning a lot of things, and I was hoping you guys were learning a lot of things back here with all the videos, the 2 videos that you had to watch and the notes that you had to take. So I'm letting you know today is going to be Friday, and it is January 10th of 2020. I want you guys to get full credit for the work that you do in my class. So I need to let you know that I came in after school and I looked through all the learning logs to see who did what. From period 6 and 7, this many people did not take their notes in their learning log. Even though I had printouts that you guys could keep at your tables, and even though I made videos and all you had to do was copy from the video. In my 4th and 5th period class, this many people did not take notes. That's still 1, 2, 3, 4, 5, 6, 7, 8. So 8 people so far from period 4, 5 are not going to be able to participate in the chip party on Monday. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 people from my 6, 7 group are not going to be able to participate in the popcorn and chip party on Monday unless they finish their work. So if you know of somebody whose name is going to be written on the whiteboard, because right now it's blank because I'm going to do the lesson, but after I do the lesson, I'm going to write up the names of the people that didn't do their Frayer model and didn't do their notes from yesterday. You have an opportunity today on Friday to get it done. Please get it done so that you can participate in our popcorn and chip party on Monday. So you guys know I keep my word. So I am definitely promising that if people do not do the work from yesterday and today, they're not going to be able to participate in that popcorn and chip party. Now I know that there is one student of mine in 6, 7 who does not have a learning log, and I am not holding him accountable for writing in his learning log because he doesn't have one. That's fine. But you know what? He still did his Frayer model. And when I go on Google Classroom, I'm going to check to see who went on Google Classroom for free computer time, even though they weren't supposed to do that unless they had all of their work completed. And I'm going to check on periods of 4 and 5, and I'm going to check on periods 6, 7. So again, please do your work. Remember, whether I'm here or I'm not here, we have STAR behavior expectations. S is for strive to do your best. Please always strive to do your best. Don't make it about me being in the classroom. Strive to do your best. T is for take responsibility. Take responsibility for not doing your work and get it done. Even though a lot of people got their work done, there are actually a lot of people that didn't. A is for act appropriately. Acting appropriately means that when I leave directions up on the whiteboard and I make it so easy for people to take notes, you need to do it because it's part of your grade. And R is for respect self and others. Please respect yourself enough to do the work so that you can get a good grade in my class. Remember, we're in 2nd semester and everybody's preparing to transition to 7th grade and to 8th grade, so I need you to do your work. So we're going to go ahead and start with today's lesson now that I've lectured you guys on how to behave. I do also want to say that I'm very proud of the people that got the work done yesterday. I looked through all the learning logs and I was able to see how many people got the work done and used nice penmanship. And I could tell the people that put forth effort, I could tell. So thank you very much for doing that because you really did it for yourself. But it makes me happy. So thank you very much. And remember, I'm all about you growing up to be happier than me, you growing up to make more money than me, and you growing up to be smarter than me. So let's go ahead and get started with our math lesson. So for today's math lesson, in your learning log, on your input side, I'm going to go ahead and start with the essential question. And this time I'm going to shorten it right here to the EQ. This is our essential question. The essential question is still going to be, how can I use properties of operations to generate equivalent expressions. Oops, I'm sorry, I misspelled that. Try that again. Expressions. Question mark. That's our essential question. How can I use properties of operations to generate equivalent expressions? The operations we're talking about are addition, subtraction, multiplication, or division. We have to look at how do we use those to generate equivalent expressions. Yesterday, we did have some that you were working on, but today we're actually going to work with decimals. So I'm going to write up our first sample question. So our first sample question is, select the expression equivalent to, and I'm going to write it here. So we're trying to find what's equivalent to negative 2x plus 8.1 y minus 9x plus 5.3y. Okay, now as I'm looking over here, something is different from yesterday. So when we look over here to the I notice and I wonder, the first thing that I notice about this, is that I see x's and I see y's. So I'm going to erase that. I see x's and I see y's. Okay, so I'm going to write that over here. I notice x's, x and y in the expression. I notice that there are x and y's in this expression. Now the other thing I wonder, what do I wonder? Well, I'm just letting you know I wonder how I can generate an equivalent expression with decimals. Question. Okay, so I'm going to go ahead and draw this little squiggly line between because I know it can get a little bit confusing, so I'm going to go like that so we can see the difference. Okay, and I'm going to draw another little squiggly line right here so we don't get confused. So what I notice is x and y in the expression. I see them there. How can I generate, I wonder, how can I generate an equivalent expression with decimals? So over here what I also see is that 8.1 is a decimal and 5.3 is a decimal. Okay, so now I'm going to look over here, but we still have to use the very same process that we used yesterday, even though we're still working with decimals. Now, we have to figure out which one of these are equivalent expressions. And yes, I want you to write these on your input side. So our first one is negative 11x plus 2.8 plus 2.8y. So that's one option. The next option is 7x plus 13.4 y. Okay? The next one is negative 11x plus 13.4 y. The next one is 7x plus 2.8 y. Okay, so we have to figure out which ones of these are actually equivalent expressions of this expression here. Which one of these? So we have to start working it out. And the first thing that we need to do is what I want you to do. You need to determine which operation you're going to use. Are you using addition, subtraction, multiplication, or division? Are you using addition, subtraction, multiplication, or division? Which one are we using? Well, I look over here and I can see that I have subtraction and I have addition. So I'm not using multiplication or division. I am using addition and I am using subtraction. So I'm going to circle it up here too. These are the two that we are using. Those are the two operations. We're just using these two. Now, let's go ahead and figure this out. Now, remember from yesterday, the very first thing that I do step one, I have to rewrite my expression. Rewrite expression. step one, rewrite the expression. So I'm coming over here, I'm going to rewrite it. Negative 2x plus 8.1y minus 9x plus 5.3y. So I rewrote it. Now I'm going to come over here, and the second step I'm going to do is I have to draw a square around my like terms. So step number 2, okay, draw squares around like terms. Okay, so first we rewrite the expression, and next we draw squares around like terms. So I'm coming back over here. I'm going to take my green and I'm going to draw a square around plus 8.1y, and I'm going to draw a square around plus 5.3y. The reason why these are like terms is because they have the very same variable. This is telling me to count y 8.1 times. This is telling me to count y 5.3 times. Now, we're going to come over here, but we say, Mrs. Soto, what are we doing with the x's? Well, we have x's that are a different like term. So I'm going to take my other purple marker, and I'm actually going to circle these ones, okay? I'm going to circle those like that so I don't get confused. Now, when I look over here at this, all I have to do is the same thing I did yesterday. So I'm going to come over here, draw squares. So I'm going to draw circles. And. So draw circles and squares around like terms. Because step number 3 is, and some of you already know, you have to add and subtract like terms. Okay, so I'm going to rewrite that again and it's okay because I know you guys need some time to write. I have to move this over a little bit because it's taking up too much space. So I'm going to move it a little bit over here. Step 3, add and subtract like terms. Okay, so here I have step number 1, then step number 2, and then step number 3. Number 1, I have to rewrite the expression. Step number 2, I have to draw circles and squares around like terms. And then step number 3, I have to add and subtract like terms. How did I do that? That's exactly what I did. So now I'm going to come back over here, and I'm going to come over here to these two, and I'm going to, and remember, I'm trying to find which one of these matches this. Which one of these, and there might be 2, there's probably going to be 2, is an equivalent expression of this expression here. So I'm going to go back, and remember, I can only add and subtract like terms. So right over here, I have negative 2x, negative 9x. Okay, those are like terms. So if I have negative 2 and I'm given another negative 9, that is actually negative 11x. So just looking at that now, you can kind of see where we're going over here. Okay, so I'm going to get my green one because my green one over here says plus 8.1y plus 5.3y. So some people might get confused right now and say, oh, well, I don't know how to add decimals. So I'm going to show you real quick, okay? I'm going to write it vertically. 8.1y plus 5.3y. Okay, so I'm going to add. Okay, you're not saying there's 2 y's here. Remember, that's just the same variable. We're just going to look at the 1 and the 3. So only focus here. 1 plus 3 is 4. And there's only going to go 1 y there, just 1 y. And 8 plus 5 is 13. Okay, so I'm looking over here, and remember it was a plus. 13.4y. And this one gets a little bit close. Okay, you see that now? So this is an equivalent expression. Now I understand that you don't entirely understand this yet. I get that. but these are the notes I want you to write in your learning log. So when I come over here, negative 11x plus 13.4. Which one of these is negative 11x plus 13.4? I see it right here. Negative 11x plus 13.4y. Okay, so that matches. So then we have some other ones over here. We have negative 11x plus 28. Yeah, that's not going to work. So that's not a good option. Then we have 7x plus 13.4. Yep, that's not going to work. Then we have 7x plus 2.8. Yep, that's not going to work. So the only one that matches in this scenario is this one here, negative 11x plus 13.4. Okay? These are the notes that I want you to write on the input side. I want to see everything that's here exactly like I wrote it. Now, I'm going to come back over here to the output side. So we know how we did it. Step 1, we rewrite the expression. Step 2, we draw circles and squares around like terms. And step 3, we add and subtract like terms. So now we have to come over here and we have to answer the question, why is that true? So why is it true? Why is it true that if you do these things that you're going to get the right answer? It's true because it is true because you can only add and subtract like terms. It is true because you can only add and subtract like terms. You can only do that. Okay. Does that always work? I'm pretty sure you've already figured it out. Yes. It always works. Okay? Yes, it always works. There you go. So what I am expecting is in your learning log, you are going to turn to the next 2 clean pages. On this side, you are going to write the notes from the output side, and on this side, you're going to write the notes from the input side. This is what I'm expecting to see when I go through your work tomorrow after school to see if you followed my directions. And so I'm hoping that you do. I'm hoping that everybody will get the work done from today and get the work done from yesterday so that they can participate in the popcorn and chip party on Monday. Okay, so I'm going to go ahead and we're going to transition now over to the simplifying expressions because I still want you to do a Freyer model for this as well. Okay.